Welcome, 8th graders, to today's Explainer. I am absolutely thrilled you're here because, honestly, we're going to explore something truly fascinating today. Have you ever looked up at the night sky or maybe watched the intricate gears of a mechanical clock ticking away and just wondered, how does it all stay so perfectly organized? You see, the universe we live in isn't random, not at all. It's actually governed by this incredible, beautiful blend of mathematical logic and divine order. Today, we're going to master a specific type of geometric movement called rotations, but we're not just going to memorize formulas, no way. We are going to see how the math of spinning objects actually points to a deeper, highly ordered design that impacts both our physical world and our spiritual lives. So get ready to stretch those minds. All right, let's dive into this. Here is our roadmap for today. First up, divine order and motion. Then, we'll cover the rules of the spin. Third, let's practice together. Fourth, your homework challenge. And finally, we'll wrap things up with education meets biblical morality. Let's kick things off with Section 1, Divine Order and Motion. You know, when we study geometry, it's really easy to look at a piece of graph paper and just see a bunch of random numbers and grid lines. But math is anything but random. It is a perfectly designed, deeply logical system of order and direction. There are actual rules that govern how everything moves, and understanding those rules, well, that gives us profound insight into how the world works. Take a look at this quote, "The Lord directs the steps of the godly." Just as this scripture from Psalm 37:23 talks about spiritual direction, the idea that our lives are guided and ordered by a higher power, geometry is all about understanding physical direction. In coordinate geometry, when we move or turn shapes, we don't just throw them anywhere. We keep them carefully anchored to a central starting point, a true north, if you will. And that brings us exactly to what a rotation actually is. A rotation turns a figure around a fixed point, which is usually the origin right at 0, 0 on your graph paper. Now, the absolutely crucial point here is that as the shape turns, it keeps its exact distance from the center. Think of it kind of like a dog on a leash tied to a post. The dog can run in circles all the way around that post, but the distance between the dog and the post, it never changes. In our math today, this fixed point is our origin. Any rotational movement we do in coordinate geometry stays tethered to this absolute center. Now, you might be wondering, why on earth do I need to know how to spin shapes on a graph? Well, rotational thinking is literally what powers the technology and the universe around you. It operates the gears in your car and complex machinery. It's the exact mathematical logic used by engineers to guide satellite orbits in space and track planetary motion. Are you a gamer? Because every single time you use your controller to pan the camera around your character, rotational math is executing that command behind the scenes. It connects deeply to physics and robotics. By learning this today, you are literally learning the language that controls the modern world. How cool is that? Moving right along, let's hit Section 2, Rules of the Spin. Okay, are you ready for the secret mathematical codes? Because these universal rules are brilliantly simple once you actually see the pattern. They dictate exactly how things turn in an orderly fashion. Let's break this down. When we start with any coordinate, let's call it x, y, and we rotate it 90 degrees counterclockwise, the rule is that the x and y swap places, and that new first number becomes negative. So xy becomes negative y, x. Now, if we rotate a full 180 degrees, so a half circle, the numbers actually stay in their exact same spots, but they both flip their signs. So xy simply becomes negative x, negative y. And for a 270-degree counterclockwise rotation, they swap places again, but this time, the second number changes its sign, making it y, negative x. These three rules right here, they are your golden keys. Let's jump into Section 3. Let's practice together. Don't worry if that felt like a lot of letters and negative signs all at once. We're going to slow things down right now. Take a deep breath, and let's let these math rules really sink in through some guided step-by-step examples. We'll take it one spin at a time. Let's look at our first example here. We are starting with point A, located at +2, +5. Our goal is to rotate this point 90 degrees counterclockwise. Remember our secret code for 90 degrees? The rule says we swap the x and y and then change the sign of the new first number. So our 2 and 5 trade places. The 5 goes to the front, the 2 goes to the back. But wait, the rule says that new front number gets its sign flipped. So that +5 becomes a -5. And there we have it. Our newly rotated point is -5, 2. See? You're just following the divine order of the formula. All right, let's try another one. Here we have point B located at -3, +4. This time, we want to rotate it 180 degrees.
So what's the rule for 180? Well, for a 180-degree rotation, the numbers stay right in their spots. No swapping. All we do is flip the signs of both numbers. So look at our starting point. The -3 flips to become a +3, and the +4 flips to become a -4. So point B smoothly rotates to 3, -4. It's essentially mirroring itself straight across that central origin point we talked about earlier.
And this brilliantly illustrates our final big rule. Look at point C at 1, -6. We are rotating it 270 degrees counterclockwise. The rule here is to swap the coordinates and change the sign of the original x value. Let's do the swap first. The -6 goes to the front, the 1 goes to the back. Now we take that original x value, which was a +1, and we flip its sign in its new spot. So it becomes a -1 in the back. Our final resting place for the point is -6, -1. If you can master this swapping and flipping, I promise you, you have mastered the coordinate plane. Which brings us perfectly to Section 4, your homework challenge. Now listen closely. I don't want you to view this homework as just a chore you got to get through. This is your chance to test your newfound logic. You've just been handed the keys to the orderly movement of the universe. Here are your 5 specific problems to conquer. Number 1, rotate point D at 3, 7, 90 degrees counterclockwise. Number 2, rotate point E at -4, -2, 180 degrees. Number 3, rotate point F at 5, 0, 270 degrees counterclockwise. Pay really close attention to that 0. Number 4 is a bit of a step up. You're going to rotate an entire triangle. Triangle G has 3 points, 0, 1, 1, 2, and 2, 1. You need to rotate the whole thing 90 degrees counterclockwise. Pro tip here, just apply the 90-degree rule to each point individually. It's that easy. And finally, number 5, write out the rule applied when rotating a point 180 degrees. I know for a fact you can apply the coordinate flipping secrets you just learned to crush every single one of these problems. Finally, let's transition to Section 5, Education Meets Biblical Morality. I want us to zoom out for a moment. We've spent this explainer focused really tightly on the mathematical center of a graph, that fixed origin point that anchors everything. But consider this powerful statement. Education without morality will hurt. I want you to really truly think about that. What is the point of being incredibly smart, of knowing how to calculate the orbits of satellites or program advanced robotics, if we just continue to make bad life choices? If we disconnect ourselves from our moral origin, from knowing right from wrong, all that education can actually end up causing harm. Just like a rotation needs a fixed origin so it doesn't spin wildly out of control, our lives need a fixed moral compass so our education is used for good and not for hurt. And that brings us to this wonderful promise from Romans 8, 6-7, which tells us that there is a promise of peace of mind to everyone who keeps their mind spiritual. This is the divine order of motion in our own lives. When we stay tethered to educational logic, like the math we learned today, and we anchor ourselves equally in spiritual truth and morality, the result isn't chaos. It's ultimate peace of mind. So I'm going to leave you with this question to ponder as you tackle your math challenge today. How will you make sure that as you grow smarter every single day, your choices stay firmly anchored to your moral center? Keep learning, keep seeking order, and I'll see you in the next explainer.